Day 37, number 7. Now, number 7 is solution, stoichiometry, where you have to balance, right? Balance and right and balance the equation. You have to, find the limiting reactant, and you got a percent yield involved. So you got to write and balance the equation. You got solutions, stoichiometry. You got molarity, volume. Right, all that is in there. So that's why this is one of my top 5 favorites, because this is very common, right? This is what we do. Now, if you read the problem, the 1 liter beaker is just the container this happens to be in. 203 milliliters of ammonium chromate. Was mixed with 137 milliliters of 0.269 molar chromium-3 nitrate to produce ammonium nitrate and chromium-3 chromate. It tells you to write the balance equation occurring here. How nice. If the percent yield of the reaction is 88%, so percent yield, 88%, what mass of chromium-3 chromate was isolated? Now that question, right away, think solid, right? So I'm going to write down ammonium is NH4 plus, chromate, CrO4 2 minus, chromium 3, and nitrate. So I got my ions written down. So we know we have ammonium chromate, NH4, 2, CrO4, and that's aqueous because it's in solution, right? I have these, whenever I'm given these molarities, right, we know it's going to be aqueous. I'm not going to give you an aqueous solution that doesn't have a molarity or vice versa. You can't have a molarity of a solid. All right. And we're going to go to chromium 3 nitrate, CrNO3, and that produces ammonium nitrate, NH4NO3, and that's very soluble. And then chromium 3 nitrate, chromium 3 chromate, and that's the solid. All right, balancing. I need 2 chromium 3s. I need, oh wow, let's try this again. Let's rewrite this problem. All right, let's try that again. We have chromium, there's a 2 there, CrO4, there's a 3 there, and that's a solid. There we go. All right, so 2 there, 3 there, and a 6 there. And that should get us what we need for a balanced chemical equation. Then we have 203 milliliters, 0.307 molar. We have 137 milliliters and 0.269 molar. And we have 88% yield. How many grams are we getting? All right, first things first, we have to find the moles. So we're going to take 203 milliliters times for every 1,000 milliliters, I have 0.307 moles of ammonium chromate. And for every 137 milliliters, 1,000 milliliters, 0.269 moles. And if we do the math, I'm going to get 0.0623 moles of ammonium chromate and 0.0369 moles of chromium 3 nitrate. Now we have to find the limiting reactant. How do we find the limiting reactant? Well, we divide by the coefficient. 0.0623 divided by 3 is 0.0369 divided by 2. If I do those, I get 0.21 and 0.018. I think I get 0.021. Right? I don't know. All right. Either way, this one is my limiting reactant, and that is my moles that I will start with. And we will erase those out. All right. So, we're going to take moles of limiting reactant, which are 0.0369 moles CrNO3. All right. Then I have to ask myself, what goes on the bottom? Well, what goes on the bottom would be moles of CrNO3 on top, moles of Cr2, CrO4, 3. And we have a 2 for chromium 3 nitrate and a 1 for chromium 3 chromate. Now we got to do the molar mass. And the molar mass, 1 mole of chromium 3 chromate happens to be 452.00 grams of chromium 3 chromate. And if we do that, I get a theoretical yield of 8.34 grams. Which is great. Now, my percent yield is equal to the actual yield over the theoretical yield times 100%. So we know my percent yield is 88%. We don't know the actual, and we know the theoretical yield is 8.34 grams, and that's multiplied by 100%. Well, the first thing we can do is divide both sides by 100. I get 0.88 equals my actual over 8.34 grams. I'll multiply both sides by 8.34 grams. All right, and then the actual ends up being, give me a second to type in your calculator, 7.34 grams of Cr2, CrO4, 3, chromium 3 chromate. Recap. So what do we do? First, we wrote the balanced chemical equation. We found the ions. Wrote the balanced chemical equation. Then we used the concentrations and the volumes to get molarity, or the molarity and the volumes to get the moles. Sorry, we got the moles. Then we divided by the coefficient to get the smallest number. We found the limiting reactant. Once we found the limiting reactant, took moles of limiting reactant to theoretical yield of product. And then we used the percent yield to get the actual yield, because we had the theoretical yield and we had the percent yield. And there we go.